kick off now, so just do a quick intro. So next up we've got Ed Allfree from Synamedia. Ed will be focusing on how low latency can be and how consistent FCC can be achieved in an OTT network, including a live demonstration, hence the setup of these technologies. Quick bio. So Ed has spent his whole career in the TV and media business, starting with 10 years working in the UK cable industry. Anyone remember 9X? Before joining Tandberg Television as a solution architect. He then lived through the acquisition cycle that was Tandberg into Ericsson and then finally into MediaKind, progressing to a head of sales while based in Stockholm. At the beginning of this year, he moved to Synamedia, where he was running the EMEA sales for video networks. Claim to fame, used to work for Roger as a CA engineer.
Okay, thank you very much. Roger definitely wouldn't say I'd progressed into sales. I know that. I think I presented here a few years ago, maybe it was 10 years ago, and I got a lot of jip from Roger about how I'd moved into marketing and sales and all of this. So probably as a reaction to that, I brought some demos along today, which no doubt will cause me no end of problem, and so on and so forth. But we're going to start and have a look at video quality metrics before we get into ABR, low latency, and fast channel change, and have a look at what's going on in that field and where. But firstly, if you don't know Synamedia, or specifically video networks, which is the part that I work for, you will of course remember Barco and Scientific Atlanta, and NDS and Arroyo, and which went into Cisco, and then we came out of Cisco back in 19 as Synamedia, and so a really strong set of customers across the world, and in the UK, of course, as well. So what I'm going to start off with is just looking at picture quality and video encoding and where we're going with that at the moment. But I'm really going to focus on a tool that sort of we make available to allow you guys to compare different encoders or different bit rates and look at how those compare. Because at the moment it's a pretty tricky thing to do, takes a long time, and we've made that pretty easy. But to start with, when we think about video quality, it's very easy to say picture quality or video quality, but really there are three elements to it. There's obviously, your picture quality, what it looks like on the screen, and the difference between the source and actually what comes out of the encoder and what you transmit and what you put on the TV. And that is the thing that we always focus on. But the other thing is about density, and as we come out of the discussion we've just had, that's about how many servers you use to do your encoding. Many operators have 600 or 700 linear channels, and they have on-demand assets, which is all being transcoded. And so, how much processing power do you need to process that? So density is another key metric that we're looking at. And then the third one is really about latency. So how long does it actually take to encode the video? Now, typically in a sort of normal DTH satellite or cable platform, you might be sort of 5 seconds from live, and a good chunk of that is from the actual encoding, probably sort of 2.5 seconds, especially if it's in a StatMux pool and things like that. But on the other end of that, if you're in live sport, or if you're in production, in the sort of contribution piece of the chain, you might be doing remote production. You might want to get your video from the Formula One track back to central office, do the production, and then you might want to put it back on a big screen at the track itself. And for that, you're going to need to get down to sort of tens or hundreds of milliseconds of encoding. So this is a key piece, and the lower you go, on the latency, typically the more bit rate or worse picture quality, you can have either, you get up here. So it's really this sort of three-way element and so just talking about picture quality on its own is not the right thing to do. So from a Cinemedia perspective, we've been working hard on this, really, back since we bought Inlet and further back than that. But there's some really key things that have happened over the last year, from smart adaptive quantization and beginning to bring in some of the AI pieces now as we drive the bit rates. And this graph is just for AVC HD. About where we've got to just in the last sort of 3 or 4 years, and obviously you could extend that back. And I think this AI piece now, not so much as part of the training and refining the algorithm. So we expect to see this curve going down, and we also expect to see obviously the new codecs coming in, such as VVC and EVC and AV1 and all of these things, and they have different effects on that earlier table that we looked between latency and processing power and so on and so forth. But if you talk to any vendor, they will show you a graph like this, and theirs will always be better than everybody else's. And obviously, ours is the best, but we need a way for you to understand and be able to measure that rather than or demonstrate it. And so, just one last thing before we get into that. You may have seen the announcement on 8K. Last week, I think it was. So again, this is another thing that's coming down the line for us. And you might remember the days in the production side anyway, when we were doing 4-quadrant 4K encoding, and then we went to a single slice. And again, that's where we are on 8K. So this is the first time we've been able to do an encode of the whole slice, rather than doing it in different quadrants in real time. And that obviously makes a big difference from ease of use and just how you do it. So 8K sort of coming, and I think we'll start to see some sort of demonstrations of that. And certainly it's in some of the screens already if you go and have a look around. But coming on to the our video quality as a service, this is a tool for you guys to use to have a look and try and compare how you look at different encodes. And this is there are a number of different metrics that people use for comparing video. PSNR, which is really a comparison of the signal-to-noise ratio before and after, and VMAF. This is probably the one that's most talked about at the moment, driven by Netflix, and as a way of comparing the quality. And what it does is it compares the source to your encoded signal, and this source could be way up the chain, or it could just be that side of the encoder, and then it gives a score, really. But it gives a score on a frame-by-frame basis to look at that picture quality. And I'm not going to go into the details of VMAF and how that works. It's published and it's driven by Netflix. But how do we use this and other metrics that are coming out to easily assess the picture quality. Now, if anyone's done any picture quality assessment in the past, you will know that some guy gives you 4 different files and says, right, can you compare the quality on these? This one's from Cinemedia, this one's from vendor X, and this one's, or he goes, I've got the different profiles, one's at 1 megabit, one's at 4 megabit, one's at 8 megabits, what's the difference between these? And then the first thing you have to do is you realize that actually they're not really the same video, or one starts 3 seconds after the other, or, and so you've got to align them up. So the first thing we've done, and it sounds really simple, but it's the thing which most people like most, is just had this tool. You just upload your assets into the cloud, and then it assesses them. And this is just the correlation between the different files that I've uploaded, and you can see it's quite clear. This is the point which they line up. And so we do this automated lineup. And so all you have to do is line up. And I'm going to take you through a bit of a demo of this now, hopefully. That is the next one. Okay, so you're going to need to concentrate a lot here. Okay, so this is my account, and I've uploaded my files up to AWS, in fact, and because I didn't want to have to do that, because obviously the uncompressed reference file is uncompressed and many gigabytes. So, and you can see that for this particular one, I've uploaded the reference file and then the same clip at 1 megabit, 2 megabits, and 4 megabits. So I'm going to go and select these in the cloud and press compare. And now it's taking those and actually assessing the different scores and having a look at them. And you can see, hope you can see all of this. It's actually come up with an average VMAF score of 48 for the 1 megabit one, and of 73 for 2, 88 for 4, and 98 for the reference file. So that's sort of kind of what you'd expect. And then it plots all of these on a nice graph. This is the reference file. The way to read this is for sort of the top 60% of these, it's giving 100% quality score, we can see up here. Then this one is the 4 megabit and down to the 1 megabit. So you can see that it's assessed the quality is much better as we go up, which is obviously what you'd expect. That's using VMAF. This is using PSNR, which is a different metric, but giving broadly the same result. And then we can compare it against each other, in fact. And so what I'm going to do here is select 2 of my assets. Maybe I'll pick the 4 megabit one, and I'll compare it to the 2 megabit one, like this. I'm just going to remove these from the picture. Okay, and so here are my VMAF scores, and it's actually on a per frame by basis for the clip that I've uploaded. And it's nice because now I can actually go in here and say, well, what's going on here? That's where you've got this massive drop. So I can already compare it against each other, but now I can actually pick that frame, go down here, except never do a demo. I'm going to go to different spots. Oh, that's nice, isn't it? Okay, and then what you should be seeing here is the slider of the 2 frames across the pictures. I'm going to try and select something else. Oh dear. Let's try this. And then go to a different point in the picture. Here we go. Oh, okay, brilliant. Sorry? Yeah, exactly. Someone's killed off. So that, you can see, allows you to compare the different profiles. But perhaps a more interesting one, he says talking quickly, hoping that the demo will work for this, is if we compare the same bit rate, encoded by different encoders. Okay, so here I've got another clip. And here you can see we've encoded the same thing, one with Cinemedia's latest encoder, one using QSV, which is hardware acceleration in the Intel chips, one by competitor A, and one by some hardware acceleration. But this time they're all at the same number of megabits per second, at 3 megabits per second. So again, here we can see this time the average VMAF scores are much more similar, but we can see that this one's highest, 88. Oh, look, it's the Cinemedia one. Excellent. And then as we come in to have a look at the VMAF scores, again, the way you have to read this is the probability that you will have this score in VMAF for each frame. So the red one on the right is looking best, and then the final one. But you can see they do cross over here, so it's interesting to see what that is. And so that's the QSV, bit of an old technology now that we'd expect to be there. So, and as we go down further, we can have a look at PSNR. And again, so now again, bit more interesting. Let's pick two, and let's be non-controversial, and we'll pick QSV here, and we'll pick the Cinemedia one here, and of course, I'm hoping like hell that it's going to work this time. And so we can see the difference, but what we can also see here is the A minus B. So this blue one here, okay, and I'm going to take all of the rest of them off, is the difference between those two that I've selected. So you can see that down here. So if we go and pick the minimum here, which is this frame down here, then if we scroll down here, oh, it's half working. Look at that. Okay, I think it might be my bandwidth issues. I'm going to pick a different slide. Okay, let's go in here. We can. I'll tell you what we'll do. We'll zoom in on the area, and then suddenly we were on QSV here, and we were on Cinemedia, and so you can see those different things. And as you zoom in, you can see, let's just zoom in once more, and then let's pick an interesting point where there's a big difference between them. Here we go. And, oh dear. Okay, so I think I've got a bit of a bandwidth problem probably in here. But we should be able to see the difference between here. Okay, so, and obviously we will try the minimum here again and have a look. And I'm going to give up trying to work out. Well, I'll tell you what, I'm going to try a different one from this because this seems to possibly be the issue. Nope, okay, there we go. But it's a really nice methodology. So what it gives you is the ability to use these metrics here, which to assess the video quality, compare to each other, whether that be the different ABR profiles that you have, or whether it be two different encoders that you're using. And then it brings in the subjective piece of it as well, because you're able to go and then analyze on a frame-by-frame basis the difference in the subjective picture quality as you go through. So anyway, so that was a quick go through our quality assessment tool. It's available for everyone to use if you come and talk to me. And then we can set you up on, and you obviously can upload your own assets into there, and you can do your own assessments. And what we're hearing from our customers is that this massively reduces the amount of work that it takes to do these assessments and to look at the different quality. And some people are now beginning to look at how they can use this in real time in the operations center, so that if they see a glitch, they can actually press a big red button or automatically upload it, and then they can do the assessments in here as well. Okay, so that was the picture quality side. Okay, so the next thing I wanted to talk about was low latency and in ABR streaming. Now, I hope I'm not going to go into what ABR streaming is, adaptive bitrate streaming. That's when, for any internet feed you have today, we transmit like 8 different profiles, between 4 to 8 of video, and depending on the capability of your device, it will pick the bitrate that it can sustain. It's always trying to get the 8 megabit version, but if it's in here with not much bitrate, it'll probably go for the 1 megabit version or something like that. So that's ABR. But the question of that is, is what latency? Now, you will have probably noticed, if you were watching the Olympics, that maybe you were like 30 seconds on average from live when you were watching something on your phone or on an app from where you were, if you're watching it on satellite or something like this. So what we're going to have a bit of a look at is the difference. But I'm going to start with a short video, which hopefully is going to explain why you want to reduce that latency. And this was something I did during the Olympics with a friend of mine in Israel. So let's run the video.
Okay, heat 6. Okay, so guys, we've got together Israel versus the UK. Obviously, the UK are going to win this. Okay, to watch the Olympic swimming together. Okay, over in Israel, we're watching it on the Yes Plus system. Over here, I'm watching it on, and we're just going to watch this. UK in lane 2. Okay, so
Israel in lane 8.
Lane 2. Israel in lane 8. Okay. Okay, what's happening, guys? You're way ahead. You've started. I haven't started yet. What's going on, guys? Oh my God. Okay, where's England on yours? I can't see. Are we ahead? Are we winning? We haven't even started over here yet. Right. Okay. So. Okay.
Okay, guys.
All right. We're about to start. Okay.
Well, we finished one lap.
Okay, you've done a lap already. We haven't even started. Oh, we've started. We've started. Okay.
29 seconds behind.
29 seconds later, we started. It's a bit crazy. Okay. England's we're doing quite well. Is that the Brits? Where's the Brits? Oh, I'm third. Where am I? Third. Am I third? Come on. Oh,
the Brits.
Come on. Okay, well,
over there.
We've only just turned the corner here. Come on, I know who's going to win. Can I place my bet now in the UK? Okay.
Yeah.
I think this guy's going to win.
Yeah.
Okay. Come on. Oh, yes, he won again.
Okay. So it's a bit of fun there, but you know that Eurosport feed was running about 27 seconds behind the Yes one and that's because Yes are using Dash low latency for their streaming, and the normal feed, that was just a normal. I don't actually know what it was, but I assume it was Dash or something like that. So and so you can see, well, I mean, most people don't watch sports events together on teams like that, but they are interacting with each other and texting them and saying, you losers, your team just conceded a goal. And if you're 30 seconds behind the guy who's telling you that can be quite annoying, obviously. And then the other big thing is betting, okay? So betting, you know, if you're betting on something 30 seconds behind the guy who's betting on it at the stadium, at the track, then you know you got a big problem, especially if you're doing some of these new forms of betting and stuff like that. So there's a big move to try and reduce latency. Okay, and so let me just go through some of the timings there. So on a typical Dash thing, you've got the encoder here, and typically that's sort of around 2 seconds for the best quality, lowest bit rate encode. Of course, you can reduce that, and every time you've sat on a Teams or a Zoom call, you've seen that encoding happening in like a quarter of a second. But you've also seen what happens to the picture quality when you try to encode that quickly, right? So you know, you can reduce this, and you can go down to a second and keep pretty good quality. But you know, CDN costs are rising, and so most people want to get the lowest bit rate for the biggest quality. But you can play with that. But we're not going to talk about that bit so much. We're going to talk about the rest of it. So in Dash, there's a sort of normally a 6-second segment. So you take 6 seconds of video, and then you publish the segment at the end of 6 seconds. Okay, and so you can't do anything for that first 6 seconds, and then you've got to publish it on the origin, and then you've got to stream it. So these CDN sort of latencies aren't so bad, sort of 300 milliseconds or something like that, compared to up there. And then you've got the big one actually, which is the client. Okay, he downloads that 6-second segment, and he can only change between the profiles, between the 8 megabit and the 1 megabit one per segment. Okay, so he's got to have a buffer of a few of those in order to be able to make decisions fast enough to move between those different profiles. So that's probably, if he's storing six segments in here, he's got an 18-second buffer in that client. Okay, so that's with MPEG Dash. Now, if we go to Dash CMAF and Dash low latency, it's pretty simple. All that happens is we're going into like 100 millisecond chunks. Okay, so each segment is chopped up into little bits. They can be published much quicker into the CDN, and they can be pulled down by the client much quicker. So he hasn't got to wait that 6 seconds until he starts downloading stuff. But he's still got a buffer, quite a few chunks in there to be able to make those sorts of decisions. So probably 20 chunks. And this client obviously makes those decisions. But what that does is means that you've gone from a latency on the previous one, probably around 27 seconds, and now suddenly we're down to 4.5 seconds. Okay? And the key thing here for many operators is that they want to get it similar to what their DTH or their satellite or their cable or their current service. So you can start syncing those together. Okay, and I'm going to come on to another technology in a minute. This is HLS for Apple, and HLS low latency. You've probably got an extra second because they use these parts rather than chunks. They're more like a second longer, and there's a bit more buffering in here. So 5.3 seconds maybe, or something around that. Now, my second demo of the day. Now, if you've got an iPhone and you point it at this, you should be able to start streaming my Dash low latency feed. If it's Android, it's a bit more dubious, and you can try one of these too. This is with an embedded Theo player, and this is the playlist. But try the HLS one, and what you will see. In fact, I'll talk about it if you want to try this out. What you will see is 2 time codes on the video if you manage to get it to play. Okay, one is the encoded before the encoder timestamp, and one is the timestamp stuck on by your phone in real time. And so if you look at the difference between those two, you can see the latency. Okay, and if everyone's done that, I'm going to, for the rest of us, I'm going to stick it in here. Okay, so this is the Dash low latency player. This time my demo seems to be working, so that's much better. And you can see that the difference between these two is about 4 or 5 seconds. I think I've got that right. Yep. So have you got it working on your phone? And what's the sort of time difference there? Okay, a bit more on the phone. It's doing some more buffering. This is obviously in a Chrome browser. If we go back, I close that one. Close this as well. So if we compare the two in here, so this is my Dash low latency. Compared to my Dash standard latency. And again, we can see, about 25 seconds, I think, difference here, something like that. And yeah, that's brought us a long way to doing what we want to do. And many people would say that 5 seconds is enough. And I can, I can actually control the client here and reduce the number of chunks that it's got buffered. So I took it down from 2 seconds buffer to half a second. You can see that the time between them has dropped, but you can also see I'm getting some network issues in here because it needs a bit more time in there. Okay, so that is sort of where we are on low latency. But obviously, 3 seconds or 4.5 seconds is still quite a lot. Okay, does anyone have any questions on this for me now? Okay, right. So then the next thing I want to go into. So that was the Dash low latency. It's a new protocol called HESP. So this high efficiency streaming protocol. And this has some interesting things. So what we actually do here is we publish 2 streams, okay? There's the normal content stream that you're receiving, obviously B and P and iframes and all of that works normally, okay? And then we also have an initialization stream. So each one of these frames, and these are the different frames, can be played immediately. They're not relying on any predictive stuff that's gone beyond. So you're not relying on the GOP. So this allows you to break into the middle of a chunk or break into the middle of a GOP structure and start playing immediately. And that has 2 effects. The first is you can do channel change much quicker. I don't know if you've ever tried changing channel on your phone or on an ABR thing. The first thing is that it depends where you break into that 6-second GOP, if they're running 6-second GOPs. If you break in right at the beginning, you've got to wait all the way till the end before you can change channel. But if it's at the beginning, so you get this massive variability. So this allows you to break in at any point. So we should see much faster channel change times. And arguably, channel change time is more important to operators than low latency because it affects every single channel, whereas low latency is only really sports channels, news, maybe Strictly Come Dancing. And so it does that. But the other thing it allows you to do is it allows the client to change between the different profiles, the 8 megabit and the 1 megabit, and at any time. It hasn't got to wait for those chunk boundaries to change between those bit rates. And so we should get lower latency as well as you change between those profiles. Okay, so now we should be able to squeeze this more and get down to something more like a 3.2 second latency. One chunk, 100 milliseconds, the network, 300 milliseconds, and only 500 milliseconds in the client because it doesn't need to buffer so much because it can change between the profiles more easily. Right, so here he runs Gauntlet again for the demo to see whether this works. Oh, and yeah, okay. There's a bit of a green problem there. I'm not sure what's going there. But so this is the HESP side of things, and this is the dash low latency. So the first thing you should notice is a slightly smaller difference in the timing on that side, and on this side, more like 5 seconds. Again, we can change the latency. Now the other interesting thing about being able to swap between the profiles at any time and being able to change channel at any time, is that one of the other key things people are looking for at the moment is synchronization, okay? So if I've got multiple camera feeds, or I've got DTH, or I've got an OTT, if I want to change between camera feeds on a Formula One car and allow the user to drive that, I need to be synchronized between the different feeds. Now, obviously, normally today, it's the client. He's downloading those chunks. He's deciding which profile he wants and stuff like that. But with HSP, it allows you to actually set the latency in the client, and that's because it can move between those profiles. And so what we're going to do is we're going to do a channel change, okay, and we're going to have a look. And obviously, if we hit the beginning of the boundary of the GOP, this will change very quickly, but this should always change quickly. Never do live demos. Should have recorded this. Let's see what happens. Okay. We definitely hit the beginning of the boundary because it was actually lower. I'm going to try that again and see what happens. Okay, so we should see as we do this, apart from the weird green effect, which is called the demo effect, not sure what's going on there, we should see a much more consistent channel change time here, and this should be much more variable. So let me click that again. And we're seeing, so as you see, this is always sort of around about 400 milliseconds, and oh, it was even better there. And there we go, and that one's now at 1.4, and 1 second there. So, and this 1 second, you can imagine if you were trying to sweep between different cameras or different pictures in something like that, that's going to be a real problem, whereas the sort of 300 milliseconds in this is going to be a lot better. So that's where we are. Now, the next thing, and in fact, what some people are using on the betting side is WebRTC. Now, that's native to browsers, so that's nice. But at the end of the day, if we are, let me go back. We've only got a second in this part of the delay, and so there are new technologies, and I think we'll see, especially in some of where it's really critical, like on the betting side of it. But that's a bit of a niche thing. So I think these are the type of area that we're moving forward onto. Okay. And so if you want to read more about our low latency solutions, obviously we saw, yes, earlier they've got it deployed across the whole network on low latency. They have it synchronized with their satellite feed, and they think that's important as they shift their customer base from satellite over to OTT. You can have a look at the HESP Alliance. It's a new standard that we're working with others on, and that is being driven forward. There's some blogs on Apple low latency and different pieces like that. So with that, that is the end of my presentation. I hope it was instructive. I'm sorry about some of my demo glitches. Next time I will learn and produce and come with a video instead. And so open to any questions.
Hi there, Martin Lee from Sky. That produced a smile. I've been trying to get through to one of my colleagues at Sky who's a GoldenEyes person, and he hasn't really given me a response yet, because I was hoping to get some news from him on VMAF. So I'm just asking you if Cynomedia has done any testing of VMAF versus the GoldenEye people who look for picture defects.
I mean, I think what you saw there is it sort of automates a lot of it, but at the end of the day, we're always going to come back to those GoldenEyes, and I think what that tool gives you is it allows you to speed up that process much faster, identify the areas where things are different, and then maybe get that 2-second clip and put it in front of those guys, and so I think VMAF does have a lot of support. In the industry, I think people are using it a lot, probably the most. We use it a lot internally on the development side. But at the end of the day, it's always going to be your GoldenEyes guys who are going to make that. But those tools are really just meant to speed up the whole process of doing that and find out the areas so they can look at that quicker.
I've seen some tools in the past, not been very impressed with them, but obviously VMAF is a generation on and has got a lot of compute power behind it, I'm sure. But at least I'll tell my colleague his job is safe for him.
Yeah, no, exactly, and that's part of it. It does take a lot of compute, and that's part of you stick it up in the cloud, and I mean the 8K ones we're limiting to 5 minutes because it takes up. I mean, if you take an uncompressed 8K file, first of all, you've got to get it up there, and then there's a massive amount of compute to run the metrics on it. With SD and HD, it's pretty fine. But being able to do it in AWS just means you can scale up and down on that really quickly. Also.
Thanks.
My name's Andy. I kind of come from a different industry, which isn't so much on the TV side, but it's a very interesting question. One of the things that we did was Thomson Reuters and the trading floors, and the panacea there was sub 1 millisecond latency, right? Because it's better to trade to not to trade. So my question is with the betting thing, because that's not my gig. they must have some rule that you can't place a bet if you're watching something on telly and it's 30 seconds late, right? Is that how it works?
So, I mean, what they tend to do is end betting like 30 seconds before the start of the race or something like that. But you can do in-match betting, right? It's just, and so, you know, you've got a lot of the professional bettors sitting at race courses on analog TVs, analog's a lot faster, right? Watching the feeds on that and betting, and you know, that's the reality. If you're betting on who's gonna, I mean, the betting companies know it and understand it, so they fully understand that, you know, they can't take a bet on the timing of a broadcast TV. They've got to take it on real time. But the punters sitting at home don't realize that there's a whole load of professionals that they might be betting against who've got something 20 seconds ahead of them. Yeah, but I think there are lots of areas. And I mean, just social media on the latency thing, you know, if your mate you know, WhatsApps you to say you've lost, and then you don't see it for another 25 seconds, then it could be pretty annoying. And so that sort of more continuous engagement around stuff makes a difference as well.
Thanks. Peter Barnett. Some years ago, one of the great goals was to minimize the latency on satellite news gathering links. Now, you can't do too much about the propagation, obviously, but are these techniques the same, similar sorts of things that are being applied in that world?
I mean, obviously for DSLNG, for satellite news gathering, it's because you want a two-way link. So you want to be talking to the guy at the other end. And so you want to keep that delay down so you can have a natural conversation. So when it comes to, this is predominantly for direct-to-consumer broadcasting, and so you know, a few seconds delay normally doesn't matter. In fact, we've seen, you know, with ABR that people will take 20 seconds delay. Obviously, you couldn't have a conversation on that. I think, you know, with the satellite news gathering, I mean, you can. And to be honest, the whole contribution space, you know, there is pressure to reduce latency there. You know, the 2.5 seconds, you know, if you do it in a dedicated piece of hardware, you can get that down to, you know, 50 milliseconds for an encode and decode if you want to, but that's really sort of dedicated hardware. You got to stick in an OB truck and stuff like that. If you want to, you know, but everyone's moving to sort of more flexibility and software-based stuff, and you know, so it's all, we're always trying to keep it down and as much as possible, but it really depends on the application for the different requirements that they have for latency.
Any more? No, I think you're getting away. Thank you very much.
Thank you very much.